Earth receives 25 times more energy from the sun than we use in the world every day. To harness that energy, we use solar panels. The panels are made from two simple elements, silicon and silver.
A solar panel consists of usually many individual solar cells. The solar cells are actually pieces of silicon that have been sliced up.
Most of the world's solar cells are made of a material called silicon, which is a very abundant element. Gallium arsenide is used more commonly in the really high-end commercial and military solar cells.
So it is the photovoltaic effect that generates electricity in the solar modules. That effect was discovered earlier, but it was actually Albert Einstein that was first able to describe it.
To put it in a simple way, these materials can absorb light energy. So what that means is that the light energy has been converted to excess electron energy. And the art in making a solar cell is to recover that excess electron energy that's been created by the light and harness it.
So the photons of sunlight strike the solar cell, and there's two layers in there. They cause an electron to jump between the two layers.
And you can think of one of them as being the positive electrode and the other is the negative electrode, just like you have in a battery. And so essentially what the photons are doing is they're pumping charge up to one of these electrodes, and then that charge can then flow back down to the other electrode and complete a circuit.
Electricity is the flow of electrons over a conductor. So anytime you're using electricity, you're basically just using a flow of electrons.
When the battery's just sitting there charged up, not connected to anything, that energy is just there waiting to be used.
I mean, if there's no conductor between the two layers, you're not going to get any electricity at all. So yeah, the conductor is essential for the solar panel to work. And the more efficient you can get the conductor, the better.
The better a conductor is, the less heat is wasted by that conductor, and that means the more power is available for your application, right? If you were to use a bad conductor, you'd basically be getting nothing out of the cell. And so that's why you really want to have the best conductor that money can buy.
The best conductor is silver. With silver, almost all of the generated voltage remains available for use.
What you need is a convenient voltage at the terminals of the cell when it's being sold for a panel. A single cell will have an operating voltage of approximately 1 volt. Okay, so what you have to do is you have to basically connect them in series, just like you connect two A-cell batteries, double A batteries in series, you get, instead of 1.5 volts, you get 3 volts.
So that's how we increase the voltage, so that when it gets to the inverter and the inverter converts it to 240 volts, the higher it is, the better. So you're going from 1.5 to over 200 volts. And that's where it's really important to be as efficient as you can in transmitting that electricity and generating that high voltage.
The basic trick behind maximizing the efficiency is to match the properties of the semiconductor to the distribution of energies that are coming from the sun. So the trick to that is to build stacks of different materials, and you're basically connecting different solar cells in series. So say one solar cell takes care of the visible and ultraviolet portion, another solar cell takes care of the infrared, and so on.
Efficiency is also important when installing panels.
To begin with, you want to have modules that are well designed and efficient. You want to have them facing directly south. You want to have them at an optimal angle for production. You want to have as little shading as possible. And then you want to try to lower the temperature so they don't get too hot. And that's why most of the time you'll see when modules are mounted, there's actually a space behind them, between them and the roof, so that creates some airflow there and keeps them cooler.
And what do you do if that's not enough?
You could add more panels and then get more power that way.
It's that simple. You need a semiconductor for the photovoltaic effect and a conductor to allow electricity to flow. But don't think you can build your own solar panels just yet.
There's a lot of details here in getting to these high efficiency numbers, and that's a real engineering challenge. The basic idea is simple. The details are incredibly difficult.
It's almost magic.
Magic it may be, but solar promises a sustainable way to power our lives. And all that is thanks to two simple elements, silicon and silver.